Alrighty, so chapter 2 is a lot about linear functions. So I don't know, at the beginning of this, a lot of you guys might already know this stuff, but I'm going to go through the lessons anyways, obviously. So throughout this chapter, you will explore the multiple representations of a linear function. You will look at tile patterns using the growth and numbers of tiles in figure 0 of these linear relationships to find specific connections between situations, tables, graphs, and equations. So one of the things I will say I like about this book is it's pretty explicit about, hey, if you have a table, you should be able to come up with a word problem. If you have a word problem, you should be able to make a graph. If you have a graph, you should be able to make an equation, and etc. all the way throughout. So I do like that they try and tie all these things together. The specific situation you will work with today is growth of tile patterns. As you work today, keep these questions in mind. How can you see growth in the tile pattern? How many tiles are in figure 0? What is the connection between the pattern and the equation? And what is the connection between the pattern and the table? So the pattern investigation. So first of all, we're asked to do this on a resource page that looks like this. I'm not sure if I'm going to use the resource page or not. I'm not sure. I guess I'll kind of go through it and see what I think about it. So what do you notice about pattern A? This is pattern A, by the way. After everyone has had a moment on his or her own to examine the figures, discuss what you see. Well, it looks like I have 4 in the middle, and then like 1 on the side, and then 2 on this side. So here I have 4 in the middle, and then it doubles here and it doubles here, and here I have 4 in the middle. I guess it doesn't double, it's just adding 1 on this side, and it's adding 2 on this side. So each time, again, I have, sorry here. All right, so I have these 4 in the middle, and then I add 1 on the left side, and then I add 2 on the right side. That looks like what's going on there. So, going through, it says sketch the next figure in the sequence, figure 4. Well, again, we know figure 4 is going to have the 4 in the middle, but now instead of 3 on the left side, it's going to have 4 on the left side, and instead of having 6 on the right side, it will have 8 on the right side. 1, 2, 3, 4, 5, 6, 7, 8. I think it looks something like that. So that's figure 4. And it says figure 0 is the name of the figure that came before figure 1. Well, we already kind of talked about that. I think that just is going to have the 4 in the middle, right? There won't be any on the left or on the right. So how much is pattern A growing? Well, it looks like it's growing 3 each time, right? So it appears to be growing 3 each time. It says how many tiles are being added with each new figure. Well, it's adding 3 each time. Color in the new tiles in each figure with a marker or colored pencil on your resource page. I don't really, I guess we'll just sort of do this. Oh, actually, I take that back. So these would be the new ones, right? So those are the new ones each time. It says what would figure 100 look like? Well, it would have 4 in the middle. I guess it would have 100 on the left side and 200 on the right side. So we'll just say 4, and then we'll say 100 on the left side and 200 on the right side, and make that one up a little taller. Assume that the starting value of any tile pattern is the number of tiles in figure 0. So in this one, it'll be 4. Assume the growth of tiles are that are added from one to the next, which will be 3. What are the growth and starting value of pattern A? Well, the growth was 3, and the starting value was 4. So now we can write that in the equation of a line. And don't forget, the equation of a line is y equals mx plus b, where this is our change, or our growth, and this is our starting value. So I'm simply going to say y equals, our growth is 3x, and our starting value is 4. And that should work. If I go over here and I plug in a 0, 3 times 0 is 0 plus 4, I have 4 tiles. So the figure number becomes the x, right? And the number of tiles becomes the y. So if I plug in a 1, 3 times 1 is 3 plus 4 is 7, I should have 7 tiles, and I do. If I plug in a 2, 6 plus 4 is 10, I should have 10 tiles. If I plug in a 3, I should have 13. And if I plug in a 4, I should have 16 tiles. And it does seem to work out well. So it says complete problem 2-1 for pattern B shown in the resource page. So I guess now I have a decision to make. I think I'm just gonna keep going with this and ignore the resource page. I know it'll look better in the resource page, but I kind of like having the questions available to me. So let's go to B. We're going to do all the same things here. So we're going to go with figure 0. So let's see how this one's going. It looks like I have this 3 that doesn't change, but then I add 2 to the bottom and add 2 to the bottom, 2 to the bottom, 2 to the bottom, so 2 diagonally. So it looks like I have this diagonal. So I'm going to go with the red and just sort of, like we talked about, circle the 2 new ones to see if this kind of helps me get an idea of what we're looking at here. So it looks like I have the one, these would have been the 2 new ones on figure 1. So for figure 0, I'm looking at something like that, right? Then I add these 2, then I add these 2, then I add these 2. So figure 4, I'm going to have these 3 from figure 0. I'm going to add 1 here and then 1 diagonally for figure 1, 1 here and 1 here for figure 2, 1 here and 1 here for figure 3, so 1 here and 1 here for figure 4. And again, these are going to be the new ones. It looks like my starting value is going to be 3, and it looks like my growth is 2. So I should have the equation y equals 2x plus 3, right? And if I plug 0 in there, I get 3. If I plug 1 in here, I get 5. If I plug 2 in here, I get 7. 3 in here, I get 9. So that definitely seems to be working. All right. The growth of tile pattern C is represented by the equation y equals 3x plus 1. So fill in the table for this one. So if I plug a 0 in, 3 times 0 plus 1, 0 plus 1 is 1. If I plug in a 1, 3 times 1 is 3 plus 1 is 4. If I plug in a 2, 6 plus 1 is 7, 10, and 13. And it makes sense. You can see my starting value is 1, just like we talked about. And you can see my growth is 3. So that makes a lot of sense. So how many tiles is each figure in pattern C growing? What is the starting value is 1. How can you use a table to determine the growth and the starting value? Well, you can see that the growth is the difference from one term to the next, right? And just how much the y changes by. And the starting value is when x is 0. So we'll say change in y. This is the delta symbol. It means change divided by the change in x, which is going to be important. Our change in x is only 1. If we had skipped 2, right, it would have been 6 divided by 2. And then 6 divided by 2 would equal 3. Or let's say we had jumped from 0 to 3. Our y would have been 9. The change in y would have been 9. And the change in x would have been 3. But we would still have a growth rate of 3. So that's how it's going to be. The change in y divided by the change of x is going to be how we determine our growth. And our starting value is just going to be y when x equals 0. Where do you look into the equation to see the growth in the starting value? Well, again, what we have here, we have an equation y equals 3x plus 1. So where do we look to see the growth? It's the number with the x. And where do we look to see the starting value? The starting value is the number by itself. So in this case, the number with the x is 3, that's our growth. And in this case, the number by itself is 1, and that is our y-intercept. All right, so moving along here. It says, look back to the growth of patterns A, B, and C. Imagine that the team next to you created a brand new tile pattern, but they refuse to show you the pattern. What information would you need in order to predict the number of tiles in figure 100? Well, what I would say is I would need to know how many were in figure 0, right? The starting point, which is also figure 0. How many tiles? And I would want to know the growth from one to the next. Once I had these things, I can write the equation, and I would just plug 100 in for the x, right? So I would multiply that by the growth, which is m, and then I would add that to the b, which is our starting point, and that would give me how many tiles were in that one. All right, so now consider pattern D shown below. Draw figure 0. Well, it seems like we're just adding 4 each time, so figure 0 would just look like this, and figure 4 would have 4 diagonals in each direction. This doesn't look great, but you can see what's happening here is I'm just adding 1 to the corner each time, so this one would have 4. Write the equation for the number of tiles in this pattern. Well, we'll say y equals 4x plus 1. Use color to show where the numbers in your equation appear in the tile. So I guess what I'll say is, let's change this one to plus 1 in green, and here's where the 1 comes from. And we'll change this to this color. Oh, that didn't go well. Change this to this color, and we'll say that this is where the 4 comes from, because I'm adding 4 each time. So that's where the numbers are going to come from. So make a table for the equation you wrote in part B. Does this information in your table match the figures in the pattern? So what we'll do is we'll say x and y. 0 should have 1, 1 should have 5, 2 should have 9, 3 should have 13, and 4 should have 17. Well, does this make sense? Figure 0 has 1, figure 1 has 5, 2 has 9, 3 has 13. 3, 6, 9, 12. Yeah, okay. And 4 has 17. So we do think so. What is the same about this pattern and pattern C? Looks like the starting point is the same. They both start with 1 tile. What is different? The growth. This one grows by 4. This one only grew by 3. What would those similarities and differences look like on a tile pattern? Well, like I said, they both start with 1 tile. However, after figure 1, D would have 1 extra tile in it. What do the similarities and differences in part D look like in the equations? Well, again, one is y equals 3x plus 1, and y equals 4x plus 1. So the difference would be right here. There's 1 extra growing. And what do the similarities and differences look like in the table? I'm sorry, and the differences. So the similarities would be that the y-intercept's the same, and the differences would be the slope. And what do they look like in the table? Well, if you look at the table, you can see, actually, I guess you can't see, bummer. The starting point is 0, 1 for both of them. And then the growth, right? It goes 4, 7. It only grows by 3 each time, but here it grows by 4 each time. So I feel like I beat a dead horse here and discussed the same thing a lot of times, but hopefully that helped if you needed it.